Well, hey everybody, this is Joe, and welcome back to the channel, and I hope you guys have had a good Christmas holiday season wherever you are. I've had a few days off, and I have been tinkering and with just some ideas, crazy ideas that may hit me. And one of those things that I wanted to do is, it was probably over a year ago, I posted a video about a couple little homemade wooden tripods that I had built. And I'll put a link down below in the description for that video. But I was dissatisfied really with how those tripods came out, functionally speaking. I wanted to do a little bit more to them. So I had some time and I decided I would play around with, see if I could upgrade and those designs of those tripods. So a lot of YouTubers and people that like to shoot video are using these Joby Gorilla Pods, and I've had one of these for a while. This is the smaller size Gorilla Pod, but it seems to work okay with the Micro Four Thirds cameras. The thing about these, of course, the legs are flexible. All these are joints. You can curve it. You can put all the legs together and kind of curve it and hold it like that with a camera on top, and then you can sit there and rotate the legs around and make it kind of a little, obviously a tripod to set wherever. And these are eminently practical, and if you buy the accessory ball head, it makes it even better, the Joby ball head with a little plate there. But I'm always liking or wanting to make stuff myself. Also, the Joby Gorilla Pods have been around for a while, but they're not that old. But I happen to have a smaller tabletop tripod that I've had for a long, long time. And it is called an Ultra Pod 2. And the thing about these, the legs fold up, and there's a little knob here, and the whole thing collapses down into a really small package, small enough that you can put it into a jacket pocket. The thing that is really interesting about the design of it that I like is the way it's built. It has a primary leg. The main leg has a 90-degree angle to it, and hinged off of that leg on either side are the two other secondary legs, and it unfolds itself so that the secondary legs are at about approximately a 90-degree angle, and when it unfolds like that, it makes an equilateral triangle base, a tripod base for the tabletop. The other thing that's kind of interesting in the way this works is you have a clamping system, one knob. There are two plates here. Bottom part of the two plates pinches this little tab that comes up off the top of the tripod, while the other part of the two plates pinches the ball head itself. So just by tightening up one knob, you can change the angle and then lock it in place. And I thought, well, that's a really cool idea, but I'd like for this to be just a little bit bigger for my bigger cameras. So I was thinking, well, maybe I can make one out of wood. Well, about a year or so ago, whenever I decided to make the first prototype of that out of wood, and I did, and I was less than satisfied with it. And this is what I came up with initially. The legs were actually about 3 or 4 inches longer than they are now. They're approximately 12 inches long now. But I wanted to mimic the angular design of the primary leg of the Ultra Pod, that 90-degree L leg, but I didn't have any materials readily available at the hardware store to do that. So what I did is I had two pieces of 1/4 inch by 1.5 inch, 1.25 inch oak. You can buy these in strips at the hardware store already finished. And I basically screwed them to a block of wood, and the primary leg is 3/4 inch poplar. And so the 3/4 inch poplar is the primary leg, and you got these two side pieces glued and screwed to them to make the kind of 90-degree angle. And then coming off those two pieces of oak, you have the two secondary legs, which are 5/8 square poplar. And I'm using some hardware with some nylock locking screws, locking nuts, I should say, down here. Anyway, the initial version of this particular tripod, because the legs were so long, I didn't want to make the angle at a 90-degree, and so it was less than 90 degrees, and I ended up using a cable loop system with some screw eyes, a loop of thin cable, thin wire, connecting all three legs, and you pull the legs tight until the wire is tight. But instead of having an equilateral triangle footprint, it was a non-equilateral triangle. I'm trying to think of the name of that. This side is much wider, and this side is narrow. These are narrower, so the center of gravity was tricky to get right on that. It was fairly easy to topple over, but the main feature of it was I had this 1/4-inch thick blade of wood sticking up above the top of it, and I disassembled the ball head mechanism. This little vane sticking up is also a 1/4-inch thick, and so I just took apart this thing and stuck it on the homemade tripod. So I used it for a while. It was okay. I didn't like the non-equilateral triangle footprint. It wasn't as stable, especially when you put a camera on it with a longer lens. It could kind of tip over. It would get the sweet spot where it was stable was kind of narrow. What I wanted to do was try to figure out if I could make my own ball head design. So a lot of the projects that I build are built from scrap materials that I have laying in my workshop in bins. And one of the scrap things I had was this wooden ball that already had a 1/4-inch hole drilled in it. This is from a craft store, and it's roughly 1.25 inches in diameter. So I figured, okay, well, there's my ball. It's certainly a lot bigger than the little 3/4 inch or whatever size ball they're using in the Ultrapod. So I'd figure I'd have to make it just bigger out of wood. And then I started looking around in my bins, and I had a strip of redwood about a 1/2 inch thick that already had a couple holes in it. It was just a longer piece with a hole in each end. And I started noticing how, well, the size of that hole, actually, it looks like it might be able to rotate in there pretty good. So what I ended up doing is laminating 2 1/2-inch pieces of redwood together to make a ball system like this. So I have these 2 pieces of redwood sandwiched together, mirror image pieces, and then I needed a bolt large enough to fit across them and put them together. And I found a hex head bolt at the hardware store that is roughly 3 inches long, 2.5 maybe. But they have these knobs that have a recessed hex hole in it, and you stick the bolt through and pull it tight, and now the bolt has a knob on the head that you can operate by hand. And so the bolt goes through the 2 pieces like that, and then you get your ball that has a 1/4-inch bolt going through it, and I'll talk about what's on top here in a minute. And then you have one of these neoprene flexible rubber gaskets that goes on that. And then at the hardware store, they sell these 1/4-20 threaded round knobs. So that's the tightening part. And then over here is the part that's going to connect to the blade on top of the tripod head. And on top of the blade where the 1/4-inch hole is, I cut a couple donuts of sandpaper and glued them to the wood so that when the blocks go in and I tighten it up, it has something to grip a hold of. And with the ball head mounted to my homemade version of an Ultrapod, here's what it looks like. So there's 2 sets of round and triangular knobs, one for the bottom part that you can loosen up a little bit and pivot the whole thing this way, and then the top ball is the main one that tightens up the ball itself. There is a certain amount of range of motion on the ball laterally, back and forth. It's a little bit limited, but this way, of course, it pivots 180 degrees or more. So what you can do is kind of orient the camera on here however you like. If you need more sideways motion, you can do it this way. Or if you need more up and down motion, you can orient the camera this way. So it depends on how you need the camera to be tilted. But basically, when this tripod is deployed like that, I have the ball head usually sticking up like that, or even sometimes I fold it back so that it's being supported right on the top corner of these pieces, and it makes it really stable. And then you can adjust the ball so it's pointing however you need it to for the camera, and then you can tighten up the controls. And when you want to go selfie shooting, you fold the legs up, and now you can adjust the ball and you can have yourself a little selfie camera. And the whole thing weighs really light. I think compared to the Joby, this is much lighter in weight because the plastics, you know, those plastics are pretty heavy on those plastic tripods, plastic and aluminum. And wood is surprisingly light, even taking into account I'm using these steel bolts and stuff, but it's still a really light tripod. So the other thing I did today with it is I put some blocks in here that enables me to open up the legs all the way to 90 degrees, and then the blocks stop it from hyperextending any further. There's one down here as well. You can fold it down and it stops it, so now you get a nice 90-degree angles on the two sets of legs in here, and that means you can have your triangular, equilateral triangular footprint for stability. So this is a Phillips head bolt that's probably about 3 inches long, a 1/4 thread, and I knew it was a little too long when I first got it, and I knew I'd probably have to cut it down somewhat. And my initial intention with this was to put some two 1/4 nuts jammed together, and then have a large fender washer, and then cut the bolt down to where you had just the right amount protruding above the fender washer for mounting the camera on. But then when I was looking around in my bin of spare parts, I found this rubber bushing, and this bushing has a 1/4 threaded nut inserted into it, and then the rest of it is hollow. And what I discovered is cool about it is when you tighten the bolt down, this rubber bushing compresses and it locks itself. So it's like a variable lock nut using the rubber tension, the compression I should say, of the rubber to lock it in place. Now, admittedly, it is a little too tall, and I could probably go to the hardware store and buy a shorter one of these bushings and then probably put a fender washer on it, and it might be a little more practical. But for now, considering the part was purchased years ago, probably hung around in my bins, and I don't really have to worry about buying another one, it works okay for now. Probably a larger fender washer, though, up here might make it a little more stable. But I wanted to be able to use this ball head on other more standard tripods that don't have this blade thing. So I had to work on an adapter. And again, as is my usual practice, this adapter is made from scraps of wood just laying around. So this is 1/2 inch plywood, and this is a piece of the 1/4 inch thick oak that's about 1 1/4 inch wide, and I had to cut a groove in here and glue the oak piece into place with a little hole, a 1/4 inch hole. Blind nut in place for the tripod mount, and so what you do there to put these blind nuts in place, this blind nut is the kind that has 2 screw holes on opposite sides of the flange. And so what you do to drill for this is you first start with a tiny little 1/16 inch drill bit and drill a pilot hole through the wood. Then you use a 5/8 Forstner bit, and you drill down through one lamination of the plywood, the top lamination of the plywood, and that'll give you enough depth to put the blind nut in with the working side of the blind nut virtually flush with the other side of the wood. It also gives you room to have a couple little tiny screws in there to secure the blind nut. It's also epoxied into place. Okay, after you've drilled your pilot hole and you take your 5/8 Forstner bit and you countersink this shallow hole here for the flange of the blind nut, then you take a 5/16 drill bit and work in from using the pilot hole on the other side, drill about halfway through, and then go on the other side and drill halfway through using the pilot hole as a guide, and you'll finish up this 5/16 hole that is just perfect for the outside diameter of the shank of this blind nut to go through the wood and have the end of it sit flush on the business end of the plate. So that's the blind nut for securing it to a conventional tripod. Here's the little blade that gives you the ability to attach that ball head, the Ultrapod style ball head to it. And this is now the ball head mounted to the adapter plate. So it's most stable if you orient the plate horizontal, so it has all this support area. And then you have, of course, your tripod bushing, which I tried to move as far up toward the mount of the camera as I could. There's a little bit of an offset, like about 1.5 inches, but it's pretty stable otherwise. And so this comes to the subject of the other tabletop tripod. Let's look at that. So I had made another tabletop tripod a while ago after I made that Ultrapod copy, and it uses a triangular shaped head, and the triangle is made from 3 pieces of 1/4 inch thick oak that are glued together, and they have a triangular top that secures them. The main feature of this tripod is that the legs pivots sideways on each facet of the triangle. So this one pivots that way, this one pivots that way, and this one pivots that way. And you have all this contact area between the facet of the tripod head and the side of the leg that'll stabilize it. There's a machine screw that goes through a hole in each one of these legs. You can see that from underneath perhaps, and it's secured by a nylock locking nut. So when the legs are extended out into a triangular fashion, what stabilizes them is that I have these screw eyes fastened on the inside of each leg and a cable system of 3 identical lengths of wire with soldered lugs, electrical lugs, and that forms a stabilizing, it's kind of like a tensegrity structure, a Buckminster-Fuller tensegrity structure. So it's kind of like a tetrahedron, if you will. And some rubber legs, rubber feet. And so it sits fairly stable, and the harder you press on it, the more tense those wire legs become. So it sort of automatically creates more tension and more stability. To mount a camera to it, I have an eye bolt that has a preset set of nuts locked together, and you simply stick the eye bolt up through the bottom of it and it protrudes up here. And you could stick a regular camera, thread a camera onto the top of this, but you're not going to be able to adjust the camera's tilt and angle anywhere unless you have the ball head adapter like this. So this ball head adapter that I made today enables me to now have an adjustable ball head on top of this tabletop tripod, so I can adjust the ball any way I want, tighten up the fittings, and it's all in a really light package, easy to carry, and very stable, very strong. And this ball head with the 1/4-20 tripod adapter plate, I can also stick on top of my larger 4-foot tall wooden tripod. There's another thing I did to the head of this tripod is I had to add these other bolts, and that was because without them you could extend the leg the other way and you could deploy them, but the wires would all be tangled up in the wrong direction. So I made it so that the legs can only fold in one direction, the direction it needs to fold in order to be stable and fully deployed with the wires nice and tense. When you decide to take the ball head off this tripod and store the tripod, a good question is, how do you keep from losing the bolt? Well, my quick, simple, expedient answer is you get a large paper clip and you simply hook the paper clip onto one of the leg wires like that. And then you can store this away somewhere, and the bolt is always secure and ready to be used again. And the ball head with its universal adapter plate I can go use on any other standard tripod with a 1/4-20 mount, or I can take the adapter off and again I can use it on my UltraPod style homemade tripod. Well, this was just some tinkering that I did this week in order to try to improve these homemade designs and make them a little bit more usable. And it's nice to create your own tools, your own photographic tools, and be able to use them and find them very functional. Now you might ask yourself, why would you want to build a tripod out of wood when you can buy carbon fiber and aluminum and all these fancy tripods? And one of the answers is that wood is surprisingly stable, surprisingly light and strong, and it also dampens vibrations quite well. So these actually make pretty good tripods. The one thing that's kind of hard to do is to make telescoping legs. Well, there's a couple other reasons why you might want to make your own things like tripods. One of the reasons is because you get satisfaction in making it yourself, and if you go out in public with that particular artifact like a homemade tripod, it's obviously homemade, but people might ask you about it. That'll give you an opportunity to share with them your passion for photography and for creativity. The other reason, though, that you might want to make your own homemade stuff like this is it's really inexpensive. all of the wood on these projects was scrap wood that I had laying around from other projects. And so the wood had already been purchased and paid for, and the only really new things might have been bolts, like for instance a ball head, those special bolts, and these knobs. You know, they're a couple dollars a piece. Everything else is just scrap wood. You know, if you had to design this from scratch to be more finely crafted, you wouldn't really be using scrap redwood. Redwood is not a great wood anyways. You would want to use something denser like oak or something, and you probably wouldn't want to use plywood. But again, the whole point of this is I'm using scraps of material, scraps of wood I have in a plastic bin that are used up from other projects. So they're free for the taking, and reappropriate it. So yeah, I could have used better wood, but this was already available, and that's one of the great things about it. But these small tabletop tripods are very practical, and my objective in designing them is that you have to use off-the-shelf hardware store components as much as possible to eliminate the need for custom machining work. It's one thing to cut wood. You can cut pieces of wood at odd angles with just careful hand tool use, but I wanted to avoid anything requiring special milling or machining of metal parts. The idea is to make this accessible designs for anybody to make. So you go to the hardware store, you start finding parts, and you start designing it in your head as you go. That's what I usually do. Well, this is Joe Van Cleve with just another update on my homemade wooden tabletop tripods. Until next time, you guys have yourselves a great day.